Today, I will introduce to you one of the workflows that we use with OFM, and I will introduce quickly our OFM software from Schlumberger, Sensia, and I need this to be like, you don't have to wait until the end of the webinar. You can ask anytime, any question related to the technology or related to the domain, okay? Very good. So, Sensia is a segment of Schlumberger and Rockwell Automation. We are focused on digital oil field automation, and we have three platforms mainly: Offset, OFM, and Avalon. Avalon is our SCADA-like system. Offset is our production data management system, and OFM is a surveillance tool that can be connected to both Offset and Avalon, and to Petrel, to Olga, to all Schlumberger application and other vendors applications. Very good. Our vision in OFM and Oil Field Manager is to have it on top of a smart database like Offset and Olga. And then we have a dashboard, a data analytics dashboard that can be connected to simulators like Petrel, Reservoir Simulator, and PipeSim, Well Simulator, and Mirac, our economical package. So then you will have insights both from data analytics and from simulations. OFM is a software that can visualize, you can collect the data, map it, integrate it, and QC it. And then you can filter, you can create a categories, you can create a layers, you can also create a very smart reports. You can create a lot of maps, 2D, 3D maps, and then you can animate those maps with the we have a very good model for forecasting that has unconventional, conventional forecasting, UPS equation, Dang equations, and you can do a smart forecast. We will explain that. And in OFM, mainly you can do well analysis, like creating a type curve, type well. You can do hydrology index. You can do pressure versus liquid. You can do churn diagnostic plots. You can do water cut analysis, estimated ultimate recovery, remaining reserve, real transit analysis, and hull plot for injectors. This is just example of what you can do with the well level, right? But you can do most of the analysis that you usually do a daily basis for well level. For the area level, you can do a lot of trend analysis. You can have a map, a depletion map, a pressure depletion map. You can see your remaining reserve. You can see the water encroachment. You can see your infill drilling maps. You can also see your petrophysical data. You can display in 3D and 2D your thickness map, porosity map, humidity map, and you calculate original oil in place volumetrically. And you can do the reservoir quality index maps, right? For the field level, also you can do a material balance, you can do average reservoir pressure, you can estimate your driving mechanism, you can calculate your recovery factor distribution, fluids contacts, and other things. So OFM can do for you all kind of analysis that you do in the office, and you can automate those analysis. You can make a dashboard, very smart dashboard, alarm system, and at the same time you can make a decisions, and you can add artificial intelligence and machine learning algorithms to the software. Excellent. So today we'll talk about screening, about how can we find candidates for our workover in a way that we optimize the production at the end. So here we have, for example, different databases. Like you could have Overset, which is from a Schlumberger, a solution from Schlumberger for production database. You can have your Excel sheets. You can have hundreds of them. You can have your own database. You can have a SCADA or Avalon from Schlumberger. So these are the different databases that you could have. Those will be integrated in OFM, and then you have link read write to the OFM software, right? We have in OFM something called data management tools that can help you to link live. So we don't load anything to the data to OFM, but you link the databases to OFM through a tool we have, and you can visualize, you can integrate all this data together. And then we do something called underperforming wells screening. And this could be done for like acidizing candidates, for water encroachment, workover, for corrosion logs, anything you want to find the candidates on, then you can run a screening method. And this will logics that we have built in, or you can create your own logic to identify those wells out of 1,000. So automatically OFM will do the screening for you. And then after the screening, it will do a recommendations, right? Then it will tell you what should you do and when should you do it. Like what kind of workover you should do and when should you do the workover, right? And then you calculate the gain of oil. It will estimate the increase in oil, estimate the decrease in water, and then go to the next workover. And you can do all the workovers in the future and build a strategic production plan based on your recommendations and calculating the gain of oil, right? Very good. All of this is using data analytics. Then you create a dashboard that can display that for you. You can monitor in per second, per minute, per hour. You can monitor the data, all the dashboards here inside. It's dynamic and interactive. Yes, there is a question. Please go ahead. Open the mic and ask. Someone raise his hand or okay. The good thing is often at the end, once it create your analytics or create your data analytics dashboard, it can be connected to Petrel, which is our simulator, right? Or any like in Aramco, we call it a power giga power, and some companies have their own simulators. Yes, go ahead. Someone trying to ask, please open the mic and ask.
All right.
Please go ahead. Yes. I cannot listen to the. Hello?
Can you hear me?
Yes, go ahead.
Yeah, I was asking if we're going to be having access to the recording, if it will be shared with us after the meeting.
Yeah, it should be. Yes, the guy who, ask the people who's recording this. Yes, we will have, and it will be published in my channel. I have a YouTube channel and LinkedIn. I will publish that in my and Facebook. So it will be published, and then we can send to everyone the link to the recording. Okay, very good. So you can see now, after you finish creating your dashboard, it can be connected to Betrel to compare the model forecasting with what you did in the data analytics. You can add to it a Python script and R scripts if you want to use a machine learning algorithms or you want to use a Python scripts, right? Very good. Any question? Now let's move to the next. One of the main thing we have in this workflow is we call it automated forecast automation and forecasting segmentation. It means what? It means it will go to your historical data and try to find a trend, either the last trend, for example, it will pick automatically the last trend, or it will go and segment your data and then choose the right one. So for example, maybe you are adding a gas lift and you want to apply workover on the top of the gas lift. So often we'll go to the time this well was started as a gas lift and follow the trend and clean the anomalies and outliers on auto mode. So it will do segmentation, it will do trend analysis, it will remove the outliers automatically, right? And then do ARBS equations or regression for ARBS equation and find for you the decline and all the reserve and everything, right? So that's the best state of art model and OFM for forecasting. We have thousands of users around the world using this, right? And we are investing a lot now in this automation, right? And it's a very powerful. It's not only this, but it will also stop where you have a reservoir constraints. For example, it will do a workover. You can see here, for example, deduct here the trend, and then it do workover, and then give you the decline after the workover, and then it's telling you at the end of this trend, you will reach your water cut limit threshold, which is maybe 90%. So you have to do workover, and then it will estimate the gain of oil using a type curve and then do the forecasting. So it could also uh, take the gas oil ratio as a threshold. It can take the bubble point pressure as a threshold, right? So it will take all reservoir and facility constraints and apply it to your forecasting with a multi-forecast. It will do oil at the same time in the background. It will do a water cut, gas oil ratio, pressure forecasting, and then combine those to give you when the well will die or when will the well stop. For example, if you have ESP wells, and those ESP wells, they will have a problem if you have a gas, if your gas oil ratio increased because you are reaching bubble point pressure. So automatically it will tell you when that trip, when should you trip your well, and when you will reach your bubble point pressure. We have a very good case study where we saved the company 120,000 barrel per day just by applying this workflow without drilling a single well. Okay. So that's our, today we'll talk more about this, how you can estimate the time that you need to do the workover, how to calculate the gain of oil, and then in a smart way, in an optimized way, in a systemic way. So if you give, for example, an engineer in any company, you give him, you ask him for a list for candidates, all the engineers, they will give the same list because this is optimized list based on the rate and based on the time to die and based on the cost, right? And all of these factors will be automatically calculated, and then you get the optimum production, the list that give you the optimum production. Very good. So the new of-M, which is now totally new, this is the look of the wells and trajectory. So even in the surface, we can have something like a profile of oil and profile of water, like a BLT logs, but in the surface. So you can see the trend, right? And I have a nice paper on this that can show you how can you display your BLT logs in the surface. And then this is the forecasting, as I told you. We have a very nice thing called annotation that will give you annotation about your events, either in the history or in the future. And then here the maps, and here actually it give you the events plus a description. So this is like alarm system, as I told you, this dashboard, it can highlight those words with the problems, give a color, give a note, even a document. So you can attach a physical document to that opportunity or to that event or to that workover. It could be a corrosion log, it could be a refrac job that you want to do, whatever, already done, right? So you attach here a timing, like start time, end time, a color code. This color code should be the type or could be the status, and then the note and the document, and all of these things can be shared with the all engineers in the company. So it's kind of sharing knowledge dashboard about the history. So if you want to do a well review, you can do it through this dashboard. We can review everything, all the intervention happen to this well, or the reservoir level or field level. Okay. I will show you a live demo at the end. Sorry, to display this. Very good. Now, you can rank your wells. You can do GIS maps, animation. You can do a 3D. And this 3D animation, you can rotate your well in every direction. Like a patrol, you can rotate it. And now we have a surface. So you can have a grid map, and this grid map also you can rotate it in 3D, right? Any questions so far? Okay, let me show you now some of the dashboards that we will create in this workshop. Let me just clean this here. So this is one dashboard where you can see that I have a maps. I have here two maps, the GIS map, and I have something called bounded map. I can color code my segmentation or my compartments or my pattern. This is a water flood patterns, invert 5 spot, and you can see I'm coloring based on the um, voidage replacement ratio, right? And here where I am over injecting and here I'm under injecting. If I click any well or any button, automatically I will get a plot here to the right and another plot here. If I zoom the plot, everything will be zoomed, right? So it's an interactive dashboard. Another dashboard is showing here 3 operators with the number of wells for each operator. I have here my wells scattered in this, and then I have here the ranking. And this is one piece. This is one dashboard. It's until if I select well here from the scatter plot, automatically it will show the plot and show in the ranking. And here in the scatter plot, I have 6 parameters. I have the lateral length in the x-axis. I have the best production in the y-axis. I have the color of the point of the well. It's showing me, for example, water cut. The size of the well show me the gas. And then the shape of the well show me the reservoir. And then I have the time on top. So I can run this and it will cluster my data like a machine learning tool. So it will actually go and show me that these wells, they have a relation with the production, but here the lateral length is not affecting. Then I can create a model. I can run a regression. I can get a linear regression, and then I can create equation, and then you create a model, and I can do clustering for all the wells here, right? I can just choose by mouse or automatically it will cluster based on a condition. So this is a very, very good here tool that can sort my wells based on performance. Yes, go ahead. Someone try to ask? Please open the mic and ask. I cannot hear anything. I cannot hear anything. Type in the chat. So very good. So this is one dashboard. For another dashboard here, you can see I have another scatter plot, which is dividing my wells to, in this corner or this quarter here, I have high water and then low oil. Here I have my water. This is my water average. Any point, any well above this line is above average. Any point here is below average in water. And this is a Y, which has the oil. And this is the oil average. So, and these wells, they have high oil, high water. These wells here, they have high oil, low water. These wells have low oil, low water, right? This could be a cum or could be the rate, and we will see this when we do the live demo. This is how to find a candidates for water encroachment. If it's acidizing, then you have to use formation damage index, skin damage. Here we are using the water encroachment to understand performance-wise which well is underperforming or which well is a good well. So these wells here are the candidates. Why? Because they are producing above average, but they have a problem with the water. So for example, if I treat this well, what will happen? This well will go down here. Sorry, it will go up here and give me the highest oil and the lowest and the low water. So this gives me the optimum oil, right? This is the second, third, fourth, fifth, sixth. So this is the order that I can optimize my production based on the oil rate. If I treat these wells, right? If I squeeze cement and reperforate, maybe they have a coning, maybe they have a leak, maybe they have some breakthrough, water breakthrough. So this is how I find the candidates and do. And we have a training. We have a very nice, we call it a reservoir optimization course. It's a 5 days course that we go through this in details and we provide the manuals and we do exercise together. Even for you, I am willing to do a workshop, right? Like a 2 days workshop where we can go this in details, hands-on. Okay, very good. So now I found my candidates for workover. Here, my candidates for water shutoff. Here, my candidates for artificial lift. And here, my candidates for infill drilling. That's what we will do in the course. And this is actually the plot. If I click on any well in the here, the scatter plot, if I click on any well, for example, if I click on this well, what will happen? Then I get a plot for this one. And this is the new plot in OFM. You can see I have, this is the water curve. But in the same curve, I can display three more parameters. Like the size will be the gas, the color will be water cut, and the shape will be, for example, reservoir. And you can see now I have a refrac job done in the upper zone, number one, and it's here, it's clear. I have a detail here, and I have here the refrac job document. I have the people, I have interpretations, I have the one who did that, and then I can see after my refrac job, I get increase in oil, which is good. I get decrease in water cut, which is good, and I get increase in gas. So you can see it easily. The interpretation is very easy, and you can see there's another work over here or shock size, another work over here, right? And you can see the change after the work over. The good thing I can add with this plus, I can add my own interpretation. So it will create here annotation, take my name, and then take my note, take my document, take my interpretation, and save it. And this can be shared for the whole company. So you can do your well review online. You don't have to meet to do your well review, right? You can do it online, and then everybody can visualize. And this is usually we created between production engineers and reservoir engineers. We create a common workflows or common dashboard that both can be used. So the production engineer can see the reservoir insight, and reservoir engineer can see the operations insight. They can all see it in the same dashboard. Any question? Okay, another example is showing a report, and this report give you the water or oil compliance. If I'm producing above the target, then it will give me a red cell, and you calculate the percentage. So I have to say if it's 20% off, either more or less, then highlighted with the red color and show me the well. When I click on the well here, it will bring the plot, it will bring the target, bring the forecast, and then show me why my well is off by 20%. This is the compliance. Of course, I can combine all of these in one big dashboard, right? But I am showing you just a simple basic examples, right? This is for water flood, the injectors and producers. I can change the size of the well based on the production or based on the cum or rate. And this is a plot, right? This is for injectors. You can see here I have the whole plot. And here I have all my injectors. And then if I read the slope of any line and display it as a bubble, what I found is all these wells with the high slope, they locate in the same area, right? See, all of these wells in the same area. All these wells with the low slope or low resistance, they are in the same area. So what does it mean? It means there is a relation between my injector efficiency and the geology. So if I bring here variability map, you can see, yes, here where I have my super K, I'm losing a lot of water. Here where I have a low variability, I have difficulties to inject. This could be also a formation damage index, skin damage. And this skin damage also to show me here, I have a high skin. That's why I can recommend the workover by acidizing, or I can, do anything to improve the reservoir quality for my injector. So this is another dashboard, but for the injectors to show you how can you create and optimize your injection by plotting the whole plot with the dashboard and showing a geological data. Of course, you can have the faults, you can have everything in your structure map. And this can be also, you can map it from Petrel or you can, and also often has algorithms to create a grid map or to create those maps on fly. So if you give me, for example, the skin damage for each well, then automatically I can create for you a formation damage index map. If you give me variability for each well, then I can create a variability map, right? And then we can have, let me jump to here. We have like now a big dashboard to show everything related to my water encroachment issues or work over. And you can see now here I have a map down, colored based on different things, right? I have one map to show me a circle inside. If it's red, it means I am have a high water cut. The frequency of this could be 1 second, could be 1 minute, could be 1 hour, it could be 1 day, it could be 1 week, it could be 1 month. So you can assign the frequency and the averaging. And then you have another bubble in the back to give you the contribution of water and oil. And then you have a grid map in the back to give you the direction of the water encroachment, and then the drainage radius and the spacing between your wells. So all these one, two, three, four, five maps, all on top of each other and synchronized. And when you animate, everything gets animated in the dashboard. So for example, I found this was, they have a big problem, right? So I click on this well. Automatically, it will bring me the plot, and it will show me that, yes, there is a water breakthrough, and it was flagged by engineer Ahmad, right? Or I can do the flagging, and then this is what happened in the water. Also, it will make a report to show me the water increase and make it with the red, and then show me the ranking and where's my have the highest water, maybe this well, and show me the channel diagnostic where I have how the water was encroaching, right? And you can see this well has a very sudden increase in water. And this is signature, maybe it will tell you because you have a coning or you have channeling or you have, right? If it's a normal water breakthrough, then it give you a 45-degree line. So now it will show you the cause or what happened to your well. It will show you the status. It will show you the history and show you the report. All of these in one dashboard. Then you can decide what should you do, when should you do it, and how to do it. Okay. This example, but this is in Arabic, where you can save this and send it by WhatsApp or do it in your presentation. So this is one thing I recorded and I send it to my management, or I can put it in my slides about a dashboard showing the water encroachment and showing the animation in the bubble, animation in the ranking, and I select a well and show me the plot of that well. Okay, very good. Now, any questions so far? No questions? Okay. So what was the timing? Is it 1 hour or what's the time? How to make a corrosion workflow? And actually I have a patent on this. And I used all the machine learning algorithms. I have a master degree in machine learning and artificial intelligence. And you don't have to because in OFM we have a plug-in. We have a plug-in for Python scripts and R scripts. So you can easily add your own Python scripts and you can easily add your machine learning algorithms, right? I will show you this paper and I can share it with you. Very good question. Okay, now we'll show you the integration part. So OFM, as I told you, it can integrate, you can integrate OFM with your Petrel. I can read, I can create a complete static and dynamic model in Petrel using OFM. This could save you 30% of your time. Because OFM will collect the data, QC the data, integrate the data, and push it to Petrel. Vice versa, I can create a complete OFM project using Petrel. Why? Because I want to visualize, I want to QC, I want to do something called future matching. I want to see the data from Petrel, data from data analytics, and I can compare the two, right? So we have it now with the big companies here in the Middle East. They are using this to really check their models, right? Also with the PipeSim, if you know PipeSim is our reservoir model, well model. I can create a complete model in PipeSim from scratch. I can calibrate it. I can estimate the rate, estimate the pressure of my well based on PipeSim, and this will work in the background. And then I can also do nodal analysis. Everything that you can do in PipeSim can be done in OFM. Also, the Mirac package, our BEEP, you can evaluate all your workovers, for example, using BEEP, the cost and the revenue, and then you can decide which one is good. Also, connect with the pipe, with the offset, and connect with Avalon. This is just examples, but often could be a data hub, a knowledge hub, dashboard hub for different applications and different databases. Very good. So what we did now, we have all these solutions that we provided to our clients worldwide, and we try to group them according to the domain. So we have a production, workflow solutions, we have reservoir management solutions, production operation solutions. And I come up with like 23 solutions. Today we'll talk about the first one, which is well optimization workflow, but we can arrange for other webinars. We can talk about these topics. I will share this list with the team here, and we can select one every 2 weeks or every week. We can select a topic and we go through. And these are a practical applications or practical solutions, and one of them using artificial intelligence that I will show you now, right now. Okay. So let me go to this well integrity surveillance system number 4, which is shows these are my papers. I will share those with you. So I will just jump to number 4 because the question was about artificial intelligence and how can you use it. So we have something called, this is just example, we called well integrity surveillance and monitoring. And we use here artificial intelligence, machine learning algorithms to really identify something called the corrosion index. And I have a patent on this. So corrosion index is something new that I created to really give you something like a type curve for corrosion that can be used to estimate the status and the rate of corrosion in your casing and cement bounding. Sorry. So first thing you do is you have to identify the challenges and the objectives. For any workflow that in the oil industry, the most big challenge was multiple source of data. We have logs in a log format, we have markers, we have deviation survey, we have all of these are different formats, different sources, and it's for petroleum engineers, it's very difficult to have them all in one platform. So we can in OFM get them all in one platform, right? We can integrate, we can relate all of these together, and then to be able to monitor the data, the corrosion rate and the corrosion status. And then we can identify those parameters affecting my corrosion using artificial intelligence. And then I can, estimate, or I can find the candidates for my corrosion log and corrosion workover. Okay, so workflow is like this. And we have a workshop, we can go through these workflows by gathering the data, queuing it, mapping it, creating the index, using the Python scripts, right? And then we can feed a dynamic workflow. We can feed back your model with your results. So you can improve your decision in the future, right? So like you go and you train your OFM in a set of data, and every time you increase that set, and then it increase the accuracy. You know this, but this is a machine learning concept, right? So you gather the data from the logs, from the last file, from the corporate databases, and you QC it, and you do this QC tool. We have 86 logics that can QC all your data types, and this is a major thing, you have to do it. And then you identify the parameters that could affect your corrosion, like formation water salinity, H2S, all of these. And then you start to do a workflow where you put all these parameters in one database, like overset, and then you create your dashboard using machine learning. So this, as you can see, I have these parameters, and I have now I'm doing my Python scripts to create something called model for corrosion index, and then I can map it as a map here, and I get all the parameters. This is by itself is another webinar, but I'm just showing you the guy who asked about machine learning, right? So then you can have these different analysis, sensitivity analysis to see which parameters is it affecting, and then how can you come up with the final model, okay? And then how can you integrate and get the dashboard, show the well integrity. Here you have a brochure, for example, for each annulus, and then you can see the alarm system to show if you have any issue with your well, and then you can have an advisory system. Another one for water flooding, right? So today we will focus now in the well optimization workflow. So let me go through the slides, and then we go through the actual live demo. So we call it the smart workover system or well optimization workflow. First, you have to do for all your wells, you have to find which well, how to do a workover, and when should you do the workover. And then you connect this to the corporate level, and then you have it in a one dashboard at the end so you can monitor. So first thing you do is you have to gather the data and QC it as usual for any workflow. Then you have to do the smart workover system mapping, and you can visualize the data. You have to find the candidates and final ranking, and then you have to integrate this, right, monitor it, and then have like a complete workflow, a dynamic workflow that can be saved. You don't have to do it from scratch every time. So while the data is streaming to the model, it will give you today's status, right? So it's like a live study or a workflow. So do the QC first. You visualize the data, all kind of data, corrosion logs. You can display it as a digital data, open hole logs, lithology, markers, everything, wellbore diagram, cross section. See, all of this can be done in OFM. So OFM is not a tick log, it's not Petrel, it's a combination of all to give you a very good platform that you can visualize all the data in one platform to make a quick decision using data analytics combined with artificial intelligence and machine learning. So it's a tool that can give you a 5 minutes or 5 second decision. You don't have to do a study. You don't have to make a model. Just by using, as you know, all of you, by using this, you with data, which is the new revolution, right? By using data analytics, you can come up with maybe the right decision, or you can go deep and then do a deep study. But at least it will give you alarm. It will highlight those words with the issues and then tell you how to do action. Very good. So you get familiar with the field by getting the logs, getting the markers, deviation survey, production, whatever. And then you start with number one, which is how can I find my candidates for water encroachment? So again, as I showed you in the beginning, I have here one scatter plot showing the actual rate, instantaneous rate, another scatter plot showing the fume rate, and then I have ranking and I have a water encroachment map down. So now automatically the system, it's go to do animation and then it will show you those wells uh, you should do work over on them to optimize production. So the system identify these wells, 1, 2, 3, 4, 5. These wells now, this is today, these wells are producing above average of oil, that's the oil rate down, and above average in water. And this well is giving me the highest water. This will give me the best oil production in my field, but it's producing water above average. So which one you think that we should work over on? So this is the first one, because if I do work over on this well, what will happen? This well, it will get less water, and then it will be, it will come, so yeah, this is the water here. This is the oil. I'm sorry, it's the oil is down here in the X. So this well is having the highest oil rate, because this is oil, right? So this oil, it has the highest oil rate and has some water. And this is my best wells because they are producing above average in oil and low average in water. So if I treat this well, it will come down here with a 45 degree. So it will be the best well with the lowest water. This is second, third, fourth, fifth. I do this in the sequence like this, then I will optimize my production because this is a good producers, but they have a water issue, right? And now I can select them, highlight them, and automatically the system will highlight those 5 wells and show me the historical of each well. Like this well was producing good, and then suddenly it has a water encroachment. This well has a work over here. This well has a work over here. And it will show this during history. Let me repeat this so you can see it clearly, right? So I can monitor and I can find the status of those candidates that I should run the work over on them. This is a very simple dashboard, but it could be complicated. In the actual project, when we do, we have to look for other things like oil water contact, perforation density. There's a lot of things you have to make a decision on, but this is a very basic dashboard to show you how can we identify those wells. Okay, Very good. Now let's go to the second dashboard. Of course, we have also in the first one, we have to do one for acidizing, like when should I do my acidizing job for these wells have a skin damage. So here I have my formation damage index against KH, against the reservoir quality, and then I have the map, and then I have automatically the list of the wells candidates for acidizing. Same thing, right? I will do this animation. Automatically, the system will select for me those wells that they are candidates for acidizing. Very good. Then I will go to the third, which is I do more analysis. I'm using now the heterogeneity index to understand how the well is behaving. I have bubble map on top of my other grid maps, like permeability, porosity, whatever, to identify and to understand, to create first a KPIs, and then to understand why this well is behaving like this, right? Is it because it's a normal? Is it because you have high water encroachment, whatever? So now I found the candidates. Now the second step is to find when the well will die. Because now I know this well, it should be done first, but maybe the second well will die first, right? So then it will change the ranking. So for example, this well, you notice this well, automatically OFM will select this as a last workover, and then it will stop here for the oil because it reached my water cut limit. You see, my water cut threshold is 90%. So often will stop here until you cannot produce anymore. You have to do a workover. Could be gas oil ratio, could be bubble point pressure, whatever, right? But it will ask you do nothing scenario. To tell you this scenario, I cannot produce anymore. Not because I reach my economical rate, not because you have a time limit, no, because you reach your reservoir constraint, which is a water cut or facility constraint. Then what should I do? Then you design a workover. Okay, I will do workover now here. So what will happen? How much oil I will gain? So automatically Open will create a type curve or a type well, either from the offset wells or from the reservoir level, and or from the history of the well, and then calculate the gain of oil until you will gain this much of oil. And then continue. And maybe you reach again the 90%, and then do again the gain of oil, and then continue. Again, you reach again until you get the last drop of oil. So this is called optimization. How can we get all the oil in optimized way, systemic way, to get most of the oil of my well using a workover, right? And now I can re-rank my wells because I know now based on production, which one should I do first. Now, based on the time that I should do the workover, I know which one I should do first. Combining this ranking, I come with the final ranking. Of course, you have to see the cost and other things, right? Third one, dashboard, is to find the cause of this problem, right? By running Chan diagnostic plots. This is good for oil, and I have uh, 3 papers on this. I modified the Chan. Chan is as an engineer. He was ex-engineer in Schlumberger, and he developed a kind of type curve, normalized curve. He collect all the oils with the coning effect, channeling effect, and then he found after drawing the water oil ratio against water oil ratio derivative, he found that each will have a special signature. And he published a good paper by just drawing the water oil ratio with the water ocean derivative against time lapse, you will find the signature. And then you can identify if this well is a cone, has a cone effect. You can see, yes, from his paper, this well has a coning, this well has a leak. And then after identifying those issues, you can easily design your workover. So first we found the candidates. Second, we found the time that we need to do the workover. Now I identify what kind of workover should I do. Any question? All of this using data analytics, right? There's no simulation here. Very good. Now we reach the final step where I show all my wells which is a field level now. You can see my field was, I start in the beginning to increase my production, which is normal. And then I get a plateau where I have a constant rate or a stable rate. And then my field start to decline, right? And this is a dangerous, right? Because I have to do something now because I'm losing. Now, I have two scenarios, as I told you. Do nothing scenario, which as you can see here, often will run. If you don't do the work over, what will happen? Remember this plot? If you don't do the work over, what will happen? You will be, you have to stop your well here. When you stop this well, this well will die, right? Unless you do something, because I reach here 90%. I cannot produce from this well. So I will lose the well if you do nothing. So often we'll do this do nothing scenario, which is this one. How many wells you will lose if you do nothing? So I have here 57 wells. After 5 years, I lost half of my wells because I did nothing. I reach my gas oil ratio limit. I get my bubble point limit. I get to my water cut limit, and I did nothing. So I lost. I have to stop 50% of my wells, and this is how much I will lose in production, the forecast. And then it will calculate for you the first work over. So if you do the first work over, this one, then it will show you how many wells you will save. This is the line, how many wells for first, for second, for third, for fourth. So you can go to the most, all the workovers that can be done in your field and how much you can optimize your production. This approach, it will give you the optimum, the best production you can get in a systemic approach. If you run this by 100 engineers in your company, they will get to the same results. Of course, you have to apply your engineering. You have to thoughts. You have to do more analysis. But at least this is a surveillance tool. This is like it will update itself every minute. It will update this forecast every day. It's a dynamic. It's like you go and watch your stocks or you watch your gold prices, whatever. It's like changing every day. So this dashboard is changing every day. It's a dynamic. We are not running a study. It's a dynamic. It's like feeding the data. Automatically, it will give you the results. And here's the final ranking. You can see my well here, and the red is the gain of oil, right? And then I can rank it based on the maximum gain. Of course, this could be in dollars or could be in barrel, whatever you want. Very good. Now, let's go now. I'll show you a live demo if you have no question. Any question so far? Showed you just for work. When you do water flooding, you have to look for injectors. This is when you do work over also, because what happened is you need to understand the time to break through. So you divide your field to different patterns or segments, and you relate your wells by streamlines. This is another topic we can talk later. And then you have to do balancing. You have to see how much you inject to how much you produce. We call it a VRR. And it's very important to optimize production, right? Because you want to minimize the water. So you have to see which injector that's really making a breakthrough. You have to reduce it. You have to control that, right? So we have to study this. We call the sweep efficiency, the vertical sweep efficiency, and the area sweep efficiency, right? There's a lot of things in the water flooding. Let me go. Let me go to the water flooding section, but it's not our topic today. So in the water flood, we talk about everything: workover, production, injection, and then we can create these maps to see the effect of injectors in my producers and to do some balancing and see how can I optimize production while using my injectors. It's another subject, another topic. We can arrange maybe the next topic. We'll talk about water flooding and how can you make your injectors efficient to optimize your production. Did I answer your question? I hope yes. Okay, excellent. Very good. Now let me show you often. Let me show you the magic. So this is the latest OFM 23.3. If you open it, it will give you this window. Let me open my project here. I can see my wells here. I have 106 wells. I have to run my license. I'm sorry. While I'm running my license, and you have any question, please let me know and tell me how much time left. And if you want to have introduction to OFM, we can arrange for that because I assume everybody knows OFM. But if you like to have another webinar to introduce OFM in general to show you the functions, things new, we can arrange for another webinar. Just talk about OFM software. I think I have some question in the chat. How much the water cut level? Yes. So based on your facility, how much your facility can handle separators and other things, right? Based on your plant. So production engineers, they know that the limit. So sometimes you have 80% limit, 90, based on the field, based on the plant, based on the facilities, right? How much you can handle water, right? Some companies will go to 90%, some companies will go to 80%. And based also on your strategy. You don't maybe want to reach to high numbers because you don't want to damage your reservoir. So it has many factors that you decide um, which threshold you want to select. This is if you can organize an off-M tutorial section. Yeah, I think the next topic will do only for off-M, and then next for water flood. The cause of water, of course, the injectors, the aquifer, the leaks, because we have a driving mechanism. Who is pushing the oil to the top? Water, right? You have a water and it's like a piston drive. It just pushes the oil up, right? But because of maybe you have a not homogeneous reservoir, then you have something like fingering. Then the water will go and have a highway and then just jump to the well. We call it coning, right? And we have this coning, you just stop the oil, and because of the different densities, it will stop the oil because it's only one door. Imagine you have two persons, you want to go from the same door. One person is a very strong, one person is a weak. So what will happen? The strong person will just push that weak and he will go to the door. So the water will push the oil out and he will go to the well because of the density difference and because of the variability and other things, right? And then you have to do work, you have to stop, or maybe because of just moving the water table up, then you get the water. A lot of reasons for water encroachment. Yes, most of my projects I'm using pipe sim at the same time. Why? Because sometimes you don't have a test, like you don't have the pressure at the bottom, flowing bottom hole pressure. You don't have it, it's not measured. So you have to use pipe sim to estimate the pressure, right? You have to use pipe sim to do another analysis, like sensitivity analysis. Which shock size, which artificial lift that I should use to improve my production. So BibeSim, of course, which will help. And we have a very good integration with BibeSim. How to take an account, salt deposit and other will complete in the integrated work over planning. Very good. So what I just showed you is like alarm, right? Like you have now someone is knocking your door. Then you have to take some action. So by knowing this well has a problem in the rate and whatever, then you have to add this mechanical or like is it water? Is it so you have to do a lot. What I showed you is a basic, but we have a course, 5 days course. We go through all of this. We go all the possibilities, right? Today, just like a quick, and the good thing about OFM, you can customize it yourself. I don't have to write, I will show you now. I don't have to write a single code. You you have just to have some programming sense, but you can do everything by yourself. Let me, I hope I answered all the questions. Yeah, here we are in this example, we are showing two things, the skin damage and the water encroachment, right? We are not, other things like mechanical, we're not covering, but it will be covered in the course, in the training course. But here, very simple, we are talking only two factors, water encroachment issue and the skin damage issue. Just remind me, I will have like maybe 10 minutes at the end to just be sure I can get all your question. May I please some comparison of them with gap? Yeah, gap is like a pipe sim, is a reservoir modeling, well modeling, right? Of M is a surveillance tool. Of M is, if you know Spotfire, it's Spotfire Plus. It's like it will give you the ability to create maps, monitor the data, do some workflows. I will show it to you now. Maybe you will get better understanding. So I will run now my OFM, and then I will open my project. So this is now OFM. You can see the wells here. You can see the map. You can see my analysis and see the dashboard is coming. So I will start. So we have this classic OFM, which is now obsolete. How to make plot, how to make forecast, how to make report, grid maps, contour maps. All of these are the classic OFM, which is now, it will be obsolete. The new OFM is this one. When you click on the analysis, you get this new icons. This is the new OFM. This is how to create a dashboard, right? So for example, you click in the mapping, then it will give you a GIS map. You can see your wells. If you go, you can see the Google Earth here. You can see the actual wells, and this is actual field in United States, right? I can change my map in the background. I can have the streets. I can have different maps, structure map, whatever, right? So you can see your map in the GIS format, and then you can have here 20 maps, like bubble map, grid map, contour map. Here. This is, we'll take it in the topic of showing you the water, the OFM functions, right? But this is the mapping, right? And here you can have the plotting, ranking, scatter plot, reporting, forecasting, type curve, CDF, cumulative distributed function, all of these 3D map, like how can I see my water encroachment in a 3D, right? Or gas, whatever. Then it will give you a 3D map where you can animate and you can see the 2D and 3D. But this is not our topic today. And you can change the colors. This is the functions. So I promise you, we will have a one webinar that we cover all of these functions. But now let's focus in our workflow, which is how can we first select my candidates for workover. So I have this nice dashboard. Then I told you I have here, these my 5 wells, 1, 2, 3, 4, 5. This is the first one for workover, second, third, fourth, fifth. And here I can track each one to see. I can take this to another screen. And in the next release, you can publish this in the web. So it will be cloud-based. So you can have this after you create an OFM, you can publish it in the web and you can send it by link to your management. They can run it from their iPhone or iPad, right? You don't have to have OFM to run this. Now you can see I start from day one and it will show me the changes of this for every day or every minute. I just make it fast because I'm running it every month for the last 50 years. Just make it fast now. And you can see this is my candidates. I can click on any well. It will show the well location here, the well location in the map, the plot, right? It's a dynamic. You can see I click on this one, click on this one, right? It will highlight my well here, my well here, my well here, location, you can see. And then this is the final five, and you can see each well performance. So now I found with this my candidates for workover for water encroachment. Another one is for acidizing. Let me just close this. And then I run something called my forecast. Acidizing, I have it in another workflow, but here I will show you now. This is my well, this is my oil, this is my water. And I can see here my water limit is 99%, right? And then automatically my well oil will stop here because it reached 99% water. And then I can design my workover by saying introduce here a workover, and then I will put it here manually, but I can say the increase manually is 100%, but I can read it from a type curve. Just to demonstrate, I will show you now my workover after I design it. See the workover here? So I designed my workover now. This is do nothing scenario, and this is workover scenario. And then I can continue, design the third, fourth, fifth. Of course, this is a complicated thing. This is a one webinar just to show you the forecasting. Forecasting is a multi-phase. It has tight gas. And you can just click here. You can see all these options for forecasting. You double click here. You can see all these options for the forecasting. If you click anywhere, this is a new option. It has a wizard. You click anywhere, it will show you the different options, right? Different options you can change. And we have automation. So I can say, for example, I want to automate this. I go to the forecast here manager, and I will say run an auto forecast using workover scenario for all my wells and take care of my water cut. And if I run this, see the speed, it's doing it for 100 wells. And it's taking the oil forecast using the water cut limit, and then estimate how much reserve, how much estimated reserve, and when should you stop your well. And this is very important because now I know which well I will use, but I want to know when the well I will die, so I can introduce my workover, and then I will introduce it and then calculate the gain of oil. So this step is like you see it here as one click, but you have to configure it. You have to put the automation, and then you can run it, right? And to configure it and everything, I will show you how to do that. If you have any question, please ask. If you have any question, does it tells you the type? Yes. We'll go now through the type. Very interesting. When does the course? 5 days. I will share with you. I will put it. I will give it to the people here. This course is run by Next, our training company, or run it by Schlumberger and Sensia. Sensia is a segment in Schlumberger. So we run this course by need. If you need, we can run it for you, or we have regular classes you can attend either online or in a class. So you can see now this is run. Now to configure this, we have to go to something called forecast template. In the forecast template, you say, I want to do my oil forecast using ARBS equations. You have Dung equations, you have other equations, right? For conventional wells. And then you put here the scenarios. I want to have a confidence interval 30%. This is like a trend analysis. It will go and clean your anomaly data from anomalies. I can select the last workover. So it will go and select the last workover, do trend analysis, and then do the historical regression using ARBS equations. And then you do the forecast. I can see the forecast. You end by time. You stop after 500 months. You stop when you reach 0.1. Or you stop when you reach water cut. Wow. You stop when you reach gas oil ratio. You stop when you reach water oil ratio. You stop when you go get gas. You stop at here. Stop, end. end based on other phase. And then you go to the other phase, which is water cut, and you put the limit, 99. You go to the other phase, which is gas oil ratio, and you put the limit, which is 1,500. Do you see the power of this? This is just using data analytics, the new revolution, without doing any simulation. If you run this, it will give you in 1 minute what should you do with your wells to optimize production. And this is now run by thousands of engineers worldwide. It's approved technology. It's not something we are trying. No. I can show you a lot of case studies on this and a lot of patterns. Okay, so this is how to set the configuration. You can set one with default scenario. You can set with the workover scenario, right? You have different templates. And we did recently a project with one company. We have like 10 scenarios. One, if I change my choke size and this choke size remain like 6 months, then if I do that, you go to that choke size and then you do decline. If I have a ECB well and this ECB well has some failures, so we have a lot of scenarios. You set the configuration of each scenario and you can run the automation. Is it clear, ya shabab? Very good. Shabab in Arabic means all, right? So I think even in Urdu and same word. Okay, very good. Now, I know now. Second question. So first is which well, I know now. When the well will die, I know now. Now, how to do a workover? Wow. Now I have Chan diagnostic plots where I can see my wells. I can see the event. You see, I have how many events here? Let me just enlarge this. See how many events I have here in this well, right? All these events. This is a signature. And this signature, I can say this is like water coning because I can see it here. It's a water coning, right? Then I can change to another well and then study all the wells and save it. So this will tell me what kind of workover I have or what kind of problem I have. So can I recommend what kind of workover I should do? So now I know the well, I know when it will die, I know what kind of workover I do. Then this is the final ranking. Final ranking, I can bring all my wells. And as I showed you in the slide, it will show me when the well will die and for the whole thing, right? Let me open another one. It's called this version. Yeah, I think this one is okay. So let me run the final. It will come now, the final ranking. Very good. You can see now, this is the wells I will gain. This is how much I will gain oil. And this is the final ranking. I can display the two scenarios, or I can bring here, I can see, give me the well number, label it. Where's that curve? I have do nothing scenario, do nothing count, and I will just say label, show. So you can see how many wells. So this scenario, you can see how many wells that I will save. And this is the final ranking. So that's the end of my course. Let me go back to my slides 1 second. If you want to reach me, I will try to share with you my slides. So this is our training agenda. In Schlumberger, we have the basic. Here's the open reservoir optimization, 5 days. And here water flooding course, 2 days. It's the basic courses. But I'm willing to give you a workshop free on how OFM is working. And this is our website. You can go to Schlumberger support and register yourself. So, and then you can send email to this customer care center. This is recorded, so you can go back So this is our support portal, and you can chat with our engineers. You send an email, we'll make a ticket. We get you back an answer within 2 days. And this is how to provide some improvement. This is our topic webinars that we did. I can give you the link and the webinar. And thank you so much. And if you have any questions, please, I'm willing to answer any question.